Welcome back, Cubs. In this video, we're going to be looking at Chapter 9, Section 3 review questions, numbers 1, 2, and 3. I'll walk through problem number 2 for you to help you with the homework. Please continue to let me know if you have any questions. So number 2 here, metallic magnesium reacts with steam to produce magnesium hydroxide and hydrogen gas. So first thing we want to do for these limiting reactant problems is to make sure that we have a balanced chemical equation. So we had, this was 9-3 section review. Number 2 here, we had magnesium reacting with with steam to produce magnesium hydroxide and hydrogen gas. So for A here, remember if you're given two reactant values, it's going to be a limiting reactant type problem. So we have 16.2 grams of magnesium and 12.0 grams of steam. So we need to do a comparison between these two reactants, and we'll go to this first product here to see which value is smaller. The smaller value will indicate our limiting reactant. So first we need to go from grams into mole. Remember that mole is our universal converter. Now that we're in moles of magnesium, let's go to moles of one of the products. So we want to go to moles of a product to see how much this particular reactant could produce. We have 0.66 moles of magnesium hydroxide. So if all of this magnesium reacted, we can get this amount of magnesium hydroxide. Now let's do the same thing, but instead of magnesium, we're going to work with water. So we have 1 mole of H2O, 18.02 grams of H2O. Remember, this value we find by adding up the parts using the masses from the periodic table. Now that we're in moles, remember this unit drops down. 2 moles of H2O and 1 mole of magnesium hydroxide. So we'll get 0.333 moles of magnesium hydroxide. So remember, when we're doing our mass to mole stoichiometry here, this first unit drops down, the second unit drops down, then we have our moles of magnesium hydroxide. If we have gram and mole together, the substance must be the same. If it's mole over mole, the substance can change. And we use the coefficients for our values here. When it's gram and mole together, mole gets the 1, gram gets the mass of the parts together. Make sure that your units cancel out. So that means this numerator, denominator units cancel out. If they don't cancel out, you have it set up wrong. So the smaller value here between these two, this indicates the limiting reactant here. So that means our 12 grams of water would be our limiting reactant. Make sure you are indicating the limiting reactant, not the product. So that means once this 12 grams of H2O gets used up, the reaction stops. So this limits how much product can be produced. If this is our limiting reactant, then magnesium would be our excess reactant. Then for B, B is asking how much excess reactant remains. Well, for that, remember we want to take big minus little, then convert to excess. So big, that's right here, 0.666 moles of magnesium hydroxide. Little, the smaller value, moles of magnesium hydroxide. Subtract those two, and we get 0.333 moles of magnesium hydroxide. But magnesium hydroxide, that's a product. We want to know excess reactant. So we need to convert from moles of magnesium hydroxide to moles of our excess reactant. Mole over mole, we can have different substances. Mole over mole, use the coefficients for our values. And then we end up with 0.333 mole of magnesium. That is our excess reactant remaining. Then for part C is asking us to find what is the mass in grams of each product that could be produced. So we need to take our limiting reactant, and then we'll do a mass-to-mass stoichiometry for both of our products. So our given is going to be 12 grams of water, and then our first unknown will be grams of magnesium hydroxide. Then we also need to find grams of hydrogen gas. So we'll have two mass-to-mass stoichiometry problems. So I'll let this focus. There we go. Here we go. Mass-to-mass stoichiometry. You start off with a mass in grams. This unit drops down. We want to get to mole, that universal converter. Then this unit drops down. Moles of what we're looking for. Now that we're in moles of magnesium hydroxide, we can go to grams by multiplying by the molar mass of magnesium hydroxide. And we get a value of 19.4 grams of magnesium hydroxide. That was C part A for grams of magnesium hydroxide. We also need to go to grams of hydrogen gas. So we start off once again with our given 12 grams of water. Now we're going to go from grams of water to moles of water. Then from moles of water to moles of hydrogen gas. Then from moles of hydrogen gas to grams of hydrogen gas. Okay, looking at just our conversion factors here. This unit, drop down. When we have gram and mole together, substance must be the same. Then our numerator unit drops down. When we have mole and mole together, we can change substances. Then mole of H2 from the numerator to the denominator drops down. We're going to grams of H2. So remember, when gram and mole are together, mole gets the 1. When gram and mole are together, gram, you add up the parts from the periodic table. When you have mole over mole, refer to the balanced chemical equation and use the coefficients. Double check to make sure that those units cancel out. Do your math and you get 0.673 grams of H2. So we have two answers because we have two products there. Let me know if you have any questions on Remind or email or the discussion board, and have a great day, Cubs.